Hey everybody! In this video we are going to introduce double angle identities. So I'm going to give you the double angle identities for sine, cosine, and tangent. There is one main one we use for sine. There are three for cosine, but really they are all the same, but we modify them using one of the fundamental trigonometric identities, so we'll recall that. And then there's one main one that we'll be using for tangent, but of course you could always use sine over cosine for tangent if you wanted. And in the second part of this same video, I'm going to derive or show you how you can come to these formulas or identities using the angle sum identities. So let's get started. You're going to take these notes. Then we'll do some guided examples in the next video. And after each guided example, I will assign you one to do on your own. All right, let's get going. The first identity that I'm going to write down is sine 2. Now you can use an x, you can use theta, you can use alpha, beta, whatever you want. So let's use, I guess let's use theta. We're going to use theta, okay? Now this is the identity. Ready? The identity is, I started writing the wrong thing. 2 sine theta cosine theta. So this is the product of three things, the 2, sine of theta, and cosine of theta. These are equivalent, interchangeable. So anytime you have this and you're solving an equation or doing an identity or whatever it may be, you can swap it out for that. Or vice versa. Maybe you have this and you only want sine in your answer, so you rewrite it like that. So that is the sine double angle identity, and you're going to memorize that. Next up, we're going to do cosine, and like I said, there's going to be 3 pieces to this one. So the first of the 3, cosine 2 theta equals cosine squared theta minus sine squared theta. All right. The next one, cosine 2 theta equals 2 cosine squared theta minus 1. And the third one, cosine 2 theta equals 1 minus 2 sine squared theta. So you'll pick and choose which one you want to use or which one you're going to use based on the rest of the problem around it. Is everything else sine? Then maybe we should just use the third one. Is everything else around it cosine? Then maybe we should use the second one. Should we maybe factor this difference of 2 squares for some reason? Maybe it's in a fraction, the numerator or denominator, and you have cosine plus sine on top or bottom, or cosine minus sine on top or bottom. And if we factor that, we get cosine plus sine, cosine minus sine. We could reduce. Whatever your circumstances may be, that could possibly be your best option. But also, just to point out, not only can I factor this using the difference of 2 squares, but I can factor these the same way. The only awkward part is the 2 would become a radical 2, and we don't really love that, all right? So this one is a little bit nicer. We don't have any irrational numbers floating around, a little smoother when factoring may be in our future. All right, so there we go. We got 1, 2, 3 for that one. Next is tangent. Now, obviously for tangent, if you were desperate and you only memorized the sine and one of the cosines, well, sine over cosine is tangent, so you could use those in that case. But for right now, I'm going to write down the following rule. Tangent double angle identity as 2 tan theta over 1 minus tan squared theta. So there we have it, 3 different identities. So have those written nice and clear for yourself. Make sure the title that I have on the screen, double angle identities, is written above your notes. Maybe put the date so you can kind of keep yourself organized. Maybe write lesson intro so you remember that this portion is the introduction to the lesson. and we could all stay really organized for the remainder of this unit, okay? Now, after we do put this in our notebook, as I said earlier, I'm going to derive these identities using the angle sum identities, which we did obviously in the last section, which was the angle sum and difference identities. All right, so I will try to do sine over here. I think I have plenty of space. So when we have sine of 2 theta, it's important to realize that 2 theta is not only 2 times theta, but it's also theta plus theta. When you think of it as theta plus theta as a sum, that's the same as thinking of it as alpha plus beta, all right? So what we're going to do is we're going to apply the sine angle sum identity to theta plus theta, since that's the same as 2 theta, and that's how we're going to come up with this right over there. So what will that look like? All right, since again, that's sine of theta plus theta, consider that your alpha, consider that your beta. Then we have sine alpha cosine beta, sine keeps the same sign, plus cosine alpha sine beta. Sorry, scooch that over. Now, what are alpha and beta? They're all theta. Do I need these parentheses? No, I was just leaving it blank to kind of show you the structure of the identity from our previous section. So cleaning it up without parentheses, sine theta cosine theta plus cosine theta sine theta. Now, what do we know about multiplication? Multiplication is obviously, I hope obviously, commutative. That means it doesn't matter if you do cosine theta times sine theta or if you did sine theta times cosine theta. So if I really stretch this out to show all steps, I'm going to reverse that order because of the commutative property. Then, this is not sine times theta, it's sine of theta, okay? Remember, of theta, like the square root of 10, not square root times 10, okay? Now, you have 2 matching pieces. I have a sine theta cosine theta on the left, I have a sine theta cosine theta on the right, I have 2 of the same thing, I'm adding them. So what does that equal? Well, so starting here, it's equals, 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 and then that leaves us with 2 of those. Of means multiply, 2 sine theta cosine theta, and there you have it. So if you forget, the angle sum identity will come in handy. Really, everything can keep developing from there. So if you really memorize the sum and difference identities and you understand how I'm deriving these right here, by knowing those, you can figure out double angle, you can figure out half angle, you can figure out power reducing. There's lots of different things that you could do, and it's pretty incredible. So I strongly suggest. So that was, let's say, derivation 1. All right, so I'm just putting a little label on that, and that's the end of it. I'll underline that 3 times. We're done. Labeled it derivation 1. So we're going to move on. Oh, a little cut off up there. Apologize. So we're going to move on, and on the next spot, I am going to derive cosine of 2 theta, and we'll do that on the side right here. So I kind of want to leave this on the screen. So I'm just going to go like that, if you don't mind. And we're going to do the next one. So I'll even use that derivation number 2. And we're going to go about this the exact same way. Cosine 2 theta. And we're going to swap out that 2 theta for theta plus theta. All right, that's our cosine 2 theta. This guy is acting as alpha, and that one right there is acting as beta. Now, that would be cosine. Remember, like you co-captains or presidents or co-whatever, buddy system together. So the cosines go together and the sines go together, or remember I kind of wrote this out as cos, the cosines, the opposite sign, and then the sines. So that could be, little cut off again, but that could be a little hint for you right over there. Make a mess. Okay. All right. So now I'm going to fill in. So it's cosine alpha, cosine beta, cosine alpha, cosine beta, but only sine keeps the same sign. Cosine is O in the middle, opposite. So it's going to be minus sine alpha, sine beta. And since, again, we're doing the angle sum identity, and we're filling in theta for both the alpha and the beta, then I could just go right ahead. Theta, 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 and theta. Cosine theta times cosine theta. Don't overthink it. Don't make it more complicated than it needs to be. Anything times itself is the same as that thing being squared. So that would be cosine of theta. Now I could put parentheses around the whole thing and square it, but as you know, we put the square here instead, and we read that off as cosine squared theta minus, same idea, not that similar, sine, sorry, minus sine squared theta, and there you have it. That was us deriving the first of 3 cosine double angle identities. So that was derivation number 2. Now, derivation number 3, I'll put right underneath it, okay? Derivation number 3. I'm going to do that because it is going to pick up from where we just left off, so it's kind of nice to have that on the screen already. Now, what do we notice about the, well, let's actually call this, I'm sorry, I'm going to call this 2a, and I'll call this 2b. This way we remember they all go with cosine, okay? What do we notice about the second version of the cosine double angle identity? Well, we don't have sine. We only have cosine. I want to get rid of this sine squared theta. I mentioned earlier, I gave a bit of a hint. I said we're going to reference or use some of the fundamental trig identities. The first Pythagorean identity we learned was sine squared theta plus cosine squared theta equals, oh boy, can I fit that? Maybe just barely. 1, okay. There we go. Okay, equals 1, all right? That was the kind of original Pythagorean identity as it comes to trig. And we could rearrange this with addition or subtraction depending, what step we're in. So what if I want to know, well, what does sine squared theta equal? Sine squared theta, what does it equal? Well, I'm going to subtract cosine squared theta from the left to get sine squared theta alone. And I'll also do that on the right, squeezing that, minus cosine squared theta. Sorry, it's squashed. And that leaves me with sine squared theta equals 1 minus cosine squared theta. So this should be familiar. We worked with this quite a bit when we were memorizing our fundamental identities, and then as we did verifying identities and solving trig equations. Okay, now we're going to substitute that in for the sine squared theta in my previous step. So right over here, sine squared theta, and then here sine squared theta is allegedly equal to 1 minus cosine squared theta. All right, and we just showed that work, and we just connected it to the identity right there. So just gonna block this off because I don't want it to blend in too much. Now, if we fill that in, cosine squared theta, you can stay. Very important step right now is this. you need, especially when you have subtraction, you need parentheses right there because we're going to need to distribute. People will say distribute. They'll remember they're supposed to distribute and then they won't distribute. So make sure you distribute. So we're going to fill in sine squared theta. We're going to replace it with 1 minus cosine squared theta. Okay? Now, this is where we can distribute that minus sign or the negative, whatever way you might think of that. That will turn the next line into cosine squared theta minus 1 plus cosine squared theta. And all we do here is we combine like terms. Cosine squared theta plus cosine squared theta is 2 cosine squared theta. And then that minus 1 just hangs out at the end. And there you have it. Derivation 2b. We just showed how we can come up with that second identity right over there. Okay? I hope that step makes sense. And I hope you could already imagine exactly how we will do derivation 2c. Derivation 2c is exactly like derivation 2b, except just the other way around. So I will do that one just a bit faster for us. So previously we had cosine squared theta minus sine squared theta. We already have that. We know that that is already equal to cosine 2 theta, okay? That was from the previous step. From here, we're going to reference the Pythagorean identity again, which was sine squared theta plus cosine squared theta equals 1. This time, I'm going to get cosine squared theta alone and use substitution and make it all sine. That means we'll subtract sine squared theta from the left, subtract sine squared theta from the right. What are we left with? Cosine squared theta equals 1 minus sine squared theta. Now this one's a little easier because you don't have to worry so much about distributing the negative, okay? Sorry, this is showing over there, but okay. We don't have to worry so much about that because it's going to be in front and we don't have a minus sign in front to distribute at all. So it's going to be a little bit cleaner for us. So that again is our Pythagorean identity. Grabbing a different color highlighter, maybe not the best colors to use, but cosine squared is going to get replaced with that right over there, and we'll do that in this step right there. So what do we got? We got 1 minus sine squared theta minus sine squared theta, which is, I'm rewriting it without parentheses as they are not necessary. Combining like terms, and there you have it. We just derived. Oh, I didn't label it. No. Derivation number 2c. I'm sorry. So squashed. And last but not least, derivation 3. Tan 2 theta, that's going to be theta plus theta, and that's my alpha plus beta. Normally we have tan alpha plus tan beta over 1 minus tan alpha, tan beta, okay? Alpha and beta are both theta, and then we wrap it up with just a little bit of simplifying. What's that going to give us? Let's see. Tan theta plus tan theta on top is 2 tan theta. Watch out that you don't put squared or 2 when you should be doing the other, okay? So be cautious, very, very cautious. Over 1 minus, now we have a product. Make sure you know the rules. 1 minus tan squared theta. And there, oh, I didn't underline that one. There we have it. Okay, that is the end of our derivation This one's awkward to underline because it has a fraction bar in it, but either way, there we have it, okay? So if you're a little fuzzy on what just happened, maybe rewind, watch it again. This one is pretty short, and I hope that you guys were all able to follow. We're gonna work on memorizing these identities, okay? These are called the double angle identities, all right? It's your responsibility to memorize them. I can't memorize them for you. Please, please, please study and memorize. And if you think you can do that, put a thumbs up. And if you don't think you can do that, put a thumbs down. Good luck. See you in the next part.